Hello everyone. So Meta has just released a very exciting and very promising new open source large language model that is much better than their previous one. I am very impressed with it. So in this video, I'm going to show you how to use these models as is to perform sentiment analysis on financial text data. And the next video, I'll show you how to further improve this by fine-tuning the model. So let me first give you an overview of the LLaMA 3 models that Meta released. So I have these two links. This notebook will be available. So in one of these links, it shows you some of the variants. So basically, you have two main pre-trained models. One is 8 billion parameters, and one is 70 billion parameters. And then they have their Instruct versions, which are fine-tuned to dialogue applications. So we're going to, in this notebook, use the Instruct versions, but later on when we're going to do fine-tuning, we're going to start from the base versions. And we're going to use the 8 billion parameter because we don't have the best GPU in the world. But anyways, these models are really good. So the dialogue one is the Instruct one is fine-tuned to dialogue applications. Just a little note, they also have like released the LLaMA Guard 2, which is like a safety model one for safety applications. But anyways, the models are based on the previous LLaMA 2 architecture, but you have now a vocabulary of 128,000 tokens and has multilingual capabilities. It uses grouped query attention in the 8 billion model parameter model to handle longer context. It's a huge improvement from the 7 billion parameter LLaMA 2 from my experience. And they train it on 15 trillion tokens on publicly available data using 24,000 GPUs. Obviously something us average Joes cannot afford. And as I said previously, the instruction tuned ones were optimized for dialogue applications. Okay. So just as a side note, if you are just to use this, you usually would not use download the model to your local machine and then or to your server and run it. Usually you would call some sort of API that has the model hosted, but we just want to show you the concept, so we're not going to do that. So instead, we're going to just like download the model into the Hugging Faces, into our collabs server. And we're going to show you with Hugging Face how to use it. We're going to do the 8 billion parameter one. So let's get started. You need to pip install the latest version of Transformers. Also, by the way, you need a GPU with enough memory. So you have to do runtime, change runtime type to GPU with enough memory. The free version, I think, does still work for this particular notebook. But you'll get disconnected quite a bit. Okay. So by the way, when you're first getting started, you need to fill out like a permission form to be able to use LLaMA 3. Maybe I got lucky, but for my experience, it actually took me a little less than an hour to get the thing approved, which is good. So once you get that approved, you're going to have this like token for the model. Like I have a LLaMA token. And then, so I have these like Hugging Face tokens. So I have a LLaMA token. So now I will put the token in here. Again, this is after you get approved, and then I'm going to say no to the Git credential. Okay, so now I have access to the LLaMA model. So the simplest thing you can do, as I said in a previous BERT video, the simplest thing you can do, like when you're using just inference on Hugging Face models, is to basically use a pipeline, because the pipeline will tokenize your inputs and then apply the model and then generate the text. So let me show you how to get started. We specify the model ID. We're going to use the Instruct, which is the fine-tuned variant. Some parameter quargs. You need this actually, because if you don't specify this, I think it loads it in 32-bit and it'll crash the free version of Collab at least. But anyways, and I specified device as the CUDA device. model ID, and the task is text generation here. So I guess I could have a task equals text generation. So this will load the pipeline. The first time it downloads the model, so it could take a bit of time. Okay. Okay, so now that we've been able to load the model, we can inspect the model. We can see the structure. We can do pipeline.model. And we can also look at the tokenizer. So you see, like, you have all this like attention mechanism and stuff like that. I don't want to get into more details. We can make another video on that. But an interesting thing here is at the end, you'll have like, because you're doing text generation, you'll have like the out features being like the number, the vocabulary size basically. And we can also look at the tokenizer by doing pipeline tokenizer. Okay, so these are the structures of these two things. Okay, so anyways, so because we're using the Instruct, the Instruct model from LLaMA 3, we need to get it in the format it expects. This is different from the pre-trained model, which doesn't have a format, but the Instruct model does. So there's this nifty helper function called pipeline.applyChat. I spelled it wrong, but apply chat template, which will make it in the right structure for the Instruct models. So you have something like this. You have these messages, and you have like, let's say role, this is the system. The content would be like, you can classify text sentiment as bullish, bearish, or neutral. And then the user gives you the content. Like I'll say, Tesla slashes Model Y prices, right? So then the helper function will can give you a prompt. So I'll show you how to do that. You do pipeline.tokenizer.apply chat template, and then you have the messages, tokenize equals false, add generation prompt equals true. Just copy this as is for now. So now we can print it, and we'll see what this does. It'll basically, this is the format that the instruction model needs. Has the beginning of text, start header ID, system and header ID, start header ID, assistant and header ID. This is like basically what it needs, right? So later I'm gonna call this full explanation, and I'll explain why in a second. Anyways, we need to define these terminators also now for the assistant responses. So assistant responses may end with a special token, end of token ID, but we also must stop generation when we get a normal end of sentence token. I honestly am copying and pasting the example from Hugging Face in the thing I showed here. So if you want more detail on this, please use that. I just want to kind of get to my main sentiment analysis examples. Okay, so now we can just basically apply the pipeline and generate text, right? And again, I'm using their examples, but like this is what's interesting for us. Okay, so basically I apply the pipeline. I give it a prompt, maximum number of new tokens. I add the end of sentence token ID. This tells you like where to stop. Do sample equals false because I don't want to sample. And because there's a little bug in the pipeline thing, like I also specify temperature equals 0, but it should be that this equals false makes temperature automatically 0, because temperature is basically how random it is. And I commented this out, but top P means like you sample the top from the top number of words up until like a cumulative probability of 0.9. Top K would be sample the top K words, but we're not going to get into details. We're going to always use the deterministic version. So like I run this and ignore the little warning things. And okay, you see and I printed the whole thing. It says Tesla slashes Model Y prices, and then it says the sentiment here is bearish. The word slashes implies a significant reduction in price, which is a negative development for investors and fans of the company. The use of the word slashes also adds a sense of urgency and suddenness of the news, which could contribute to a bearish tone. Overall, this headline suggests that the news is not good for Tesla stock price. This is like a perfect response. You can't get much of a better response to this. This is amazing. Like, very impressed with this. But like, let's just say hypothetically, I just wanted just to return the word bearish, right? So we can also add to the prompt. Basically, we can tell it just answer in one response, right? And give us one word back, right? So I can kind of change the prompt a little bit. So here I do it here, and I change the messages, and I say respond with only one word, right? So the prompt would be the exact same thing, except it says respond with only one word. Okay. And again, I applied the apply chat template. And now let's see the output from this. Bearish, which is what we wanted. Just a quick note, above I set this prompt now to prompt full explanation. So I'm going to call the one that it explained on and on, the full explanation one. Because later I'll show you, we might want to get into the details later, but this is just kind of amazing, to be honest with you. So, okay. So anyways, this was a few examples. And okay, so, oops, I put this in the wrong spot. Okay, so now we're going to apply this to a data set. And the data set is a data set of sentiment analysis, which I derive from AlphaVantage, like using their news data sets and extracting the sentiment for Tesla specifically for things very relevant to Tesla. I can maybe make a video on how I got that data set. But okay, so I load this data set here, and then I read it from CSV, and we'll inspect it a little bit. We have basically a summary, and then it'll have a label which will be bearish, bullish, or neutral, and it will have a time published. Okay, so now let's just create like a helper function which gives you the prompts and the full prompts from the summaries. So basically, we'd want to turn each summary into the prompt and the full prompt, which the only difference is the full prompt does not have the respond with only one word. So let me create these functions. It's basically what we did above here with basically prompt, apply chat template, and then return prompt. Okay, so now we can use Pandas' apply method to get the prompt and the prompt full explanation. Let me just show you how one of them looks like. You can do df.prompt.iloc0, and then this will be the prompt, the first prompt. We can print it to make it nicer format. Okay, great. So now I just want to show a few examples because LLaMA 3 is not perfect, but also the labels of my data set are not perfect. Okay, so let's just maybe look at the first example, right? So the first example, the prompt says, Tesla CEO has pushed the automotive sector to gradually abandon vehicles with internal combustion engines or gasoline cars. I guess this could be interpreted as bullish. The label from the data set is bearish. I don't know, maybe this is a case where the original text made it bearish, but like the summary is bullish and we were only provided the summary. I don't know, it's hard to tell. But if we are going to apply our pipeline, we can apply our pipeline to the first prompt element. And what does it give us? It gives us bullish. Okay, but like maybe we want more details. We want to know why it's bullish. By the way, it returned this gigantic thing. And if we just want the bullish part, we need to like basically, we should probably, we should split on this thing here and just extract the bullish part. So I'll do that here. I'll do output 0 generated text dot split of this thing and take the last thing, -1. And I guess maybe before that, I should just tell you that outputs looks like this. It's kind of like a list of with a dictionary with generated text, and the list is size 1. So I do this, and then I can do generated text, and then I get the generated text, and then I added that. But anyways, I didn't want to get into too much detail. So now you just extracted, you see bullish, right? But like, maybe this is not enough information. We don't really like, I mean, it's bullish, but what's your thinking? So let's actually apply the full prompt and see what it says. So we just do, of course, the outputs equals pipeline, and we add the full prompt, and let's see what it says. What's the reasoning, right? So it says, I'd classify the sentiment of this text as bullish. The text is highlighting Tesla's CEO's effort to promote the adoption of electric vehicles, which is a positive development for the company and the industry. The tone is optimistic and forward-looking, indicating a positive outlook for the future of electric vehicles. So I buy that argument. It makes a lot of sense. So let's just look at a few price cut examples. So from my experience, and I trade Tesla way too much, unfortunately not in the recent explosion up, but and I'm always a bull. So every time Tesla cuts prices, the stock crashes. There's like literally no excuse, no other way about it. But you'll see some of the sentiment scores, labels of the data set itself, and some of the predictions from the LLaMA model are not always bearish for a price cut. So let's look at an example. Let's look at whenever the prompt contains the word cut. So we'll see an example like Tesla cuts starter prices for Model 3, Model Y in China up to. And then let's apply the LLaMA model. And you'll see it says bullish, which is kind of weird. Why on earth would it say bullish if it cuts the prices? Seems wrong to me. So the LLaMA model is wrong in this case, right? So let's look at the full explanation about why. This was the full explanation one. And as you see, the text mentions that Tesla has cut prices of its Model 3 and Model Y starter cars in China, which is likely to increase demand and boost sales. This is a positive development for the company and its investors. So from my experience, this is absolutely not right. And this is definitely wrong. Because it always crashes after that. So this is a bearish thing. Okay. So just to show you, like, by the way, the label was also bullish. So the label itself seems a bit off also. So like we're starting with a data set that might not be perfect to begin with. Okay, but let's assume it's perfect for the rest of these things. So another example is like Tesla shares were sliding about 5% in pre-market trading Friday. What happened? Electric vehicle maker lowered its prices and stuff like that. So the label I'm given in the data set is neutral, but the explanation says it's sliding 5%. It's already showing like a bearishness. This should definitely be bearish. So let's now apply the LLaMA 3 model. We can see like, okay, it is bearish, right? And we can maybe look at the explanation by looking at the full model. It's funny here, the explanation just returns sentiment bearish. So sometimes it's not perfect. Like, I mean, sometimes like it doesn't give you a full explanation. It just gives you the one word, which is interesting. So this is bearish. So this is a situation of maybe the LLaMA actually doing a better job than the other model. Okay. Okay. So okay. So this is interesting. So these are just a few examples, right? So now we can basically analyze the model performance. Let's analyze the model performance of, let's say we're going to assume all our labels of our data set are correct. Let's analyze the model performance as is using the LLaMA model. And let's see then after the next video if we fine tune this, if we can actually improve our score. So the first thing we're going to do is we're going to split our data into train, val, and test. The first 60% we're going to make for train, the next 20 for val, and the next 20 for test. I've seen examples where people use like stratified sampling, like random 40, like 60, 20, 20 splits with class weights balanced. But this is not perfect in my opinion, because often you have many articles around the same time that are very similar. So it's kind of extreme data leakage if you have it in the train and test set, like something like one article after another that talk about the exact same thing. So especially if you're using more than one news provider. So that's why I split it across time. There are some, of course, on the edges overlap. So maybe be careful of that. But the train to test set has a big gap in between, so we should be good on that front. But just the stratified thing might, the percentage of bearish, bullish, and neutral might change over time. Okay, so now we're going to apply the pipeline to all the test prompts to get the sentiment predictions. So how are we going to do that? There's better ways to do this, but what I did is I took the prompts and I just made it a list of prompts, and then I applied the pipeline and I get this test outputs. It takes some time. We should probably remove this warning. It takes some time, so let's let it run. Okay, so once it finishes, we want to extract just a prediction. Remember that we did the whole splitting thing on the end header. So we're going to do something like test predictions equals output 0 generated text that's split. And then we split on this thing like we showed you previously. And then this is how we're going to get our text predictions. So let's just show you a first 10. Okay, so like this. And then we're going to, we can do something like this. We can do df test predictions. Predictions equals test predictions. Okay, so now we can basically look at some classification metrics. So let me just show you. We can look at basically, let's say, one step before is you'll see if we do df test predictions dot value counts, we'll see that we have a few that are like not really bearish, bullish, or neutral. We have smooth, impressive, and Tesla. So it's not perfect. Let's drop these. And so basically let's just do, what we can do is we can do df test predictions that is in bearish. I like this autocomplete. And let's see if this fixes the problem. So we do df test dot predictions, and then we'll do dot value counts, and we get bearish, bullish, and neutral. Okay, great. That's what we wanted. So let's actually just set df test equals df test with these things. Oh, look how cool it is. It remembered. By the way, I didn't have this until I upgraded to Pro. So I think there are some benefits to upgrading to Pro. So now let's look at some classification metrics. So we're going to look at like the confusion matrix and the classification report. So let's df test dot label is our y, and df test dot our y actual, and our y pred is df test dot prediction. We're going to look at the confusion matrix, classification report, and the balance accuracy and accuracy score. So what did I get wrong? It doesn't have prediction because I call it predictions. So let's see how it looks. So we get balance accuracy and accuracy in the 40s. Again, remember the labels are not perfect. The confusion matrix looks like this. Looks kind of solid, honestly. Precision, recall, that sort of thing. Anyways, next video, we're fine-tuning this guy. We're going to improve this. I hope you enjoyed. If you're new, please like and subscribe. Thank you so much, and have a wonderful day.